Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve UPSC problems for the subject electric circuits. For that, I have taken Engineering Services Examination Preliminary Paper 2024. Let me start solving the problem. These are the problems taken from Engineering Services Examination Preliminary 2024. The 5 resistances, first I will read out the problem. 5 resistances of 10 ohms each are connected between terminals A and B. What is the total resistance between terminals A and B? So we need to find the equivalent resistance between terminals A and B. Now observe the network. There are two delta networks. This is one delta network and this is one delta network. Any one delta network can be converted to Y network first. Then we can solve easily. So first I'm going to convert this first network into Y network. Y network is nothing but star network. So I'm going to convert this delta network to star network. Okay. And then we can find the equivalent resistance. So I'm naming this as RA, RB, and then RC. Okay. So after conversion, the circuit will be simplified like this. Between the terminals A and B. Okay. So this is RA, RB, and RC. And then again, this is A. This is the terminal A, and here C, and then here D. Here one another resistance in series, and here also another resistance 10 ohms in series between the terminal B and D. Okay, this is 10 ohms and this is also 10 ohms. Now we need to find RA, RB, RC by star delta transformation. Okay, here all the resistances are equal in value. So RA equal to RB equal to RC. So to convert delta to star, we can find like this. To find for example, if we want to find RA, we have to search for either side resistances. The product of either side resistance by the total sum of resistances. So here to find RA, product of either resistances, here also 10 ohms, here also 10 ohms. So 10 into 10. So 10 into 10 by the total resistance is 10 plus 10 plus 10. That is 100 by 30, which is 10 by 3 ohms. Okay. So all the resistances in the Y network is 10 by 3 ohms. So we can mark that now. 10 by 3 ohms and RB also 10 by 3 ohms. RC also 10 by 3 ohms. So again this RB and another 10 ohms are in series condition. And here RC and another 10 ohms are in series condition. So let me find the series equivalent first. So the circuit will be simplified like this. Between the terminal A and B. So this is RA. And here the equivalent resistance. Series equivalent is 10 by 3. Series equivalent is 10 by 3 plus 10. 30 plus 10, 40 by 3 ohms. So each series equivalent resistance is 40 by 3 ohms. This is 10 by 3 ohms. And here also the series equivalent is 40 by 3 ohms between C and D terminal. Okay. C and D terminal. This is A terminal. Now 40 by 3 ohms. Two 40 by 3 ohms are in parallel condition. So we know the principle of homogeneity. By that principle of homogeneity, we can find the resistance, equivalent resistance. So if the resistances are equal in value and it is in parallel condition, we can find by the formulation R equivalent equal to R by number of resistances which are in parallel. Okay. So here there are two number of 40 by 3 ohms resistance in parallel condition. So we can form like this is a parallel equivalent. Okay. Parallel resistance equivalent. So 40 by 3 by 2, which is 40 by 6, that is 20 by 3 ohms. Okay. So this parallel equivalent is 20 by 3 ohms. So 10 by 3 ohms, here 20 by 3 ohms. 20 by 3 ohms, 10 by 10 by 3 ohms. Okay. So again, between A and B terminal, 10 by 3 ohms and 20 by 3 ohms are in series condition. So total R resistance between terminals RAB equal to 10 by 3 plus 20 by 3, which is 30 by 3. 30 by 3 equal to 10 ohms. Okay. So RAB equal to 10 ohms. So we can mark RAB equal to 10 ohms. Equivalent resistance between the terminals A and B. So answer option B is the correct one. Option B is the correct one. Okay, 10 ohms is the correct answer. Let me move to the next problem. What is the value of VAB in the network shown in the figure? One Wheatstone bridge network is given. We need to find the voltage between terminals A and B. So let me mark this as, so this is VA and this is VB. Okay, we need to find between the terminals, voltage between the terminals, VAB. So can we simplify like this? VAB equal to voltage VA minus VB. So VA is this terminal voltage and here this terminal voltage. And see this terminal, this is positive and this is negative. So negative is connected to the end of the 20 ohms terminal. So we can mark this as grounded terminal. This is grounded terminal and we can take this as positive and this is negative. Okay. This is negative. So VA is nothing but voltage across 20 ohms. So like that VB is nothing but voltage across 20 ohms. VB is nothing but voltage across 40 ohms. VA is voltage across 20 ohms. VB is voltage across 40 ohms. So let me find. So since A and B terminals are open in condition, this 10 ohms, see here, this 10 ohms and 20 ohms are in series condition. Okay, series condition. And then this 30 ohms and 40 ohms are in series condition. So let me find V20 ohms first. So here VA is nothing but voltage across 20 ohms and VB is voltage across 40 ohms. So now we need to use the voltage division rule and we can find the voltage across 20 ohms and voltage across 40 ohms. That is nothing but VA and VB. And then we will find the difference between that. That is VAB. Okay. So VAB equal to VA minus VB. So by the voltage division rule, by the voltage division method or rule, we can find the VA and VB. Okay. So VAB equal to, now VAB equal to, for VA, to find VA, that is voltage across 20 ohms. So for that, by voltage division rule, total voltage, what is the total voltage given? 10. Total voltage into that terminal, that branch resistance. What is the branch resistance? We need to find the voltage across 20 ohms. So that branch resistance is 20 ohms. And then the total resistance. Total resistance is, this 20 ohms is in series with 10 ohms. So 10 plus 20. And again to find VB, that is voltage across 40 ohms. Total voltage is 10 volt. 40 ohms is the respective resistance. And another series resistance is 30 ohms. So 40 plus 30. Okay. So 200 by 30 minus 400 by 70. Cancel. And here 20 by 3 minus 40 by 7. So which is 20 into 7, 140 minus 4 into 3, 120. 20 by 21. So it is equivalent to, it is approximately equal to 0.959 something. So 0.959 volt. Now we'll search for the options. The options are given as 0.86 volt in the A option, 0.96 volt in the B option. So we can conclude with that it is approximately equal to 0.96. We will round off this. 0.96 volt. So this is VAB. VAB equal to 0.96 volt. So we have used voltage division rule to find out the voltage between the terminals A and B. So option B is the correct one. Option B is the correct one. So shall we move to the next problem? Yes. So next problem is given under the topic maximum power transfer theorem. What is the maximum power that can be delivered to the variable resistor in the circuit? So this is the variable resistor given in the Wheatstone bridge circuit. Okay. So we need to find the maximum power delivered. So when will be the maximum power delivered? When load resistance equal to Thevenin's resistance. So we will write the formulation for that. First, we need to find the maximum power. It is Thevenin voltage square by 4 times of load resistance. So here load resistance is nothing but R. R is given as load resistance. So 4 times of R. So when will be the maximum power delivered? When R equal to Thevenin's resistance. So we can write the formulation as V Thevenin square by 4 times of R Thevenin. Now we need to find V Thevenin and then R Thevenin. So to find the V Thevenin, the load terminal should be open circuited. Okay. So it is nothing but VOC, open circuit voltage. So for that we can find like the previous problem. So previous problem we have done like that we can do to find the V Thevenin. Let me draw the circuit. So this is Wheatstone bridge and here okay. Now I'm open circuiting this terminals. I'm naming this as AB. So this is VAB, which is nothing but VAB equal to Thevenin's voltage, which is equal to open circuit voltage. Okay. So like the previous problem, we can solve for VThevenin's. So this is given as 60 volt. Okay. This is 10 ohms, 25 ohms, and then this is 20 ohms, 5 ohms. So take this as grounded terminal. Now we need to find the voltage across 20 ohms and voltage across 5 ohms. See here, take this as VA and this is VB. So VAB equal to VThevenin equal to VA minus VB. Okay. So now voltage across 20 ohms is VA. Voltage across 5 ohms is VB. So like the previous problem, we can solve by voltage division rule itself. So for VA, the total voltage is given as 60 into the respective resistance is 20 by another series resistance is 20 and 60. So here 20 and 10 are in series condition. Okay, so 20 plus 10 minus 60 here. To find VB, total voltage is 60 into that respective resistance. We need to find the voltage across 5 ohms. So that branch resistance is 5 by which is in series condition. 25 ohms is in series condition. So 5 plus 25. Okay. So now 60 into 20 by 60 into 20 by 30 minus 60 into 5 by 30. So now 2 and here cancelling 2. So 40 minus 10 which is VAB equal to VThevenin equal to 30 volt. So we have found out for VThevenin. Next we need to find the RThevenin. Okay. So VThevenin equal to already we found out. Now to find RThevenin. So how will you find out the RThevenin? The voltage, the given source should be short circuited. Okay, the given voltage source should be short circuited. So here, after short circuiting this condition, will become like this. So I am redrawing like this. See here, Now, this is open circuit condition between terminals A and B. And here I am short circuiting the voltage. Okay. And then rearranging the short circuit condition inside and the terminals outside. It will be like this. It will be like this. Okay, this is between terminals A and B. Now, here 25 ohms and here 5 ohms and here 10 ohms and then here 20 ohms. Okay. Now see the terminal A and B. And here also N to N connection. A terminal is connected to the one end of the 5 ohms and one end of the 20 ohms. So another end of the 25 ohms and 5 ohms is connected. So 25 parallel with 5 ohms. 25 and 5 are in parallel condition. Like that, 10 ohms and 20 ohms are in parallel condition. So let me find the parallel equivalent first. Okay. So let me find the parallel equivalent. 25 ohms parallel with 5 ohms equal to 25 into 5 by 25 plus 5, that is 30. Okay, so 6. So 25 by 6 ohms. And then let me find the parallel equivalent of 10 ohms and 20 ohms. So 10 ohms parallel with 20 ohms, which is 10 into 20 by 30, 20 by 3 ohms. And again, it will be simplified as like this. Okay. So between the terminals, this resistance and this resistance are in series condition. So 25 by 6, 20 by 3 ohms. So we can add that 25 by 6 plus 20 by 3. So which is 25 plus 3 into 2, 20 into 2, 40, 65 by 6 ohms. So 65 by 6 ohms is the orthogonal. So no need to find the decimal. So at last we can find the decimal. Now we need to find the maximum power delivered. Okay. So the maximum power delivered. What is the formulation? VThevenin square by 4 times of orthogonal. So I'm finding out here. So P max equal to VThevenin by 4 times of VThevenin square by 4 times of orthogonal. So VThevenin equal to 30 volt. So 30 into 30 by 4 into 65 by 6. Okay. Now 2, 3 gets cancelled and then it will be simplified as 270. It will be simplified as 270 by 30. And again, this will be approximately equal to 20.769. Okay, watts. 20.769 watts. Now let me search for the option. In the option D, 20.77 is given. So P max, we can conclude that P max equal to approximately equal to 20.77 watts. 20.77 watts. Okay. So maximum power will be delivered when RL equal to RThevenin. So maximum power delivered is 20.77 watts. So option D is the correct one for the given problem. So this question is under maximum power transfer theorem. Let me solve the next problem. What is the value of voltage V0 shown in the circuit? So here the simple circuit is given, one current source and another passive elements only. One is inductance, another one is capacitance. So capacitance and inductance are given in rectangular form. And then here the ammeter value is given as polar form. So either we have to convert to polar to rectangular or rectangular to polar. So here two values are in rectangular form. We can convert this ammeter value, current value into rectangular form itself. First, we will write the equation. This is the nodal voltage. So we can write the equation by nodal analysis itself. So by nodal analysis, using Kirchhoff's current law. So this is incoming, outgoing, and this is outgoing current. Okay, here also grounded and here also grounded terminal. So we can write the equation V naught by J6 plus V naught by minus J3 equal to 4 angle 90 amps. Okay. So let me convert this 4 angle 90. So what is magnitude? The magnitude of A square plus B square equal to 4. Okay. The magnitude of A square plus B square equal to 4. And the tan inverse B by A equal to 90 degree. Therefore, B by A 90 degree. Therefore, B by A equal to tan 90. Tan 90 is nothing but infinity. So, anything by 0 is infinity. So, we can conclude A equal to 0. Real part is 0. Only imaginary part is there. So, from this we can find. So, root of B square equal to 4. That means B equal to 4. Okay. Only the imaginary part. So, the total value we can convert this as 4J. Okay. So, taking this as LCM, J6, here V0 minus 2V0 equal to 4J. And then minus V0 equal to 4J into 6J minus 24. So, V0 equal to 24 volt. So, like this we can find. V0 equal to 24 volt. So, option C is the correct one for the given problem. Option C is the correct one for the given problem. So, we have solved 4 problems from the UPSC. This is Mani's Gate Tech Vision. This is a channel for engineering lectures. You can subscribe to the channel. My mail ID is dmanilecture@gmail.com. If any queries means you can mail me. Thank you very much for watching the video.